With me, we have Alexandre. We're both working at Clever Cloud, which is a platform as a service company. Alexandre is the main Pulsar guy in our company. He's managing our entire cluster and developing applications around it. Right now, mainly working on authorization and authentication in the cluster. And for me, I'm more on the R&D at Clever Cloud, working on the functional service we're presenting next and the basis of the authorization plugin we've developed. Also, I've spent the best part of the last 2 months working on the Rust client for Pulsar, and it's going well. We're soon releasing the 1.0 version. So what are we doing at Clever? We're hosting applications. So Java, Ruby, JavaScript, whatever application with the databases. And we've been recently working on providing a function as a service system. So the idea is that like you can have on AWS Lambda or OpenFaaS or systems like that, you have very small pieces of code that are run on demand without thinking about the infrastructure, how many servers, the size, or whatever, or even how much you need to scale it. All of that should be done automatically. And so this is a good service to add to our system. And very important part, it should be built on consumption. If you're not using it, you're not paying for it. Okay, so that's straightforward. So from a simple system like that, we thought, okay, maybe we have to go a bit far and do something fun. So we decided to go with WebAssembly as a function abstraction backend as a way to deploy application instead of container. So because WebAssembly is a good target for many languages, this can be then compiled directly to machine code to make something very fast. That we host in very small, very short-lived virtual machines with no operating system. We have our own hypervisor for that based on KVM. And we boot one such function on the fly for each HTTP request that you would receive, or whenever there's a message coming on a topic for which you have a function that handles that topic. WebAssembly is very nice for that kind of system because it's small, it's well contained. You can use languages like Rust, C++, Go, Haskell, Lua, AssemblyScript, Kotlin, lots and lots of languages to compile to WebAssembly. And then you have a bytecode that's very easy to sandbox. It uses a very small amount of memory. It's easy to compile to machine code. So it's like a common bytecode for many languages. I had not seen stuff like that in years. And it's not limited to browsers. So it started in browsers as a specification there, but we soon saw that it could be used almost anywhere as long as you provide a runtime with functions, with an API that the WebAssembly function can call. You can host that anywhere. Why are we using virtual machines? First, it's because they're very cheap. So we are going against what most people think about virtual machines, because it's in our DNA at Clever Cloud to use virtual machine. We do not host everything on container. We use virtual machines for every application. We boot a new one for every new version of an application. And so we know how to make them fast. And in this case, it's even smaller than the virtual machine that use Linux kernel and the standard application processes. We can just start them directly with no operating system and just the machine code that will call into the hypervisor if it needs to read from a file or get something from a network or write a log line. So we can just start a function with like 1 megabyte of RAM. That's it. They boot extremely fast in 1 millisecond. I think I can even make that faster. And this is the best isolation we can find right now at a correct price. The better isolation would be like having one core per function, and we're not there yet. So this is the best security we can have right now. There's a very limited host API, like a few functions where the hypervisor just check all the arguments, everything, and no writing directly into the hypervisor's memory. No hardware emulation, like no floppy disk that's somewhere for which we need to write drivers or emulate. No network card, nothing like that. Just standard POSIX-like API. Sorry, just went. Okay. And all of this is heavily based on Pulsar. I say that we have function that can react on a Pulsar topic, but also we have a compilation service that gets the new function to compile from a Pulsar topic. The configuration information comes from a Pulsar topic as well. So the host, the virtual machine host, just needs to listen to the network and listen to a topic to know which application to deploy or not. And metrics and logs are used as sent there as well. So it's heavily based on Pulsar, and having various topics helps us like boot a new infrastructure from scratch very easily, very fast. Can get to the next slide. Yeah. So we have Pulsar functions. What can we do with that? So compared to the current Pulsar function that you can have in your Pulsar clusters, there's no need to start one process per function. If it's not used, like we have one FaaS host and the function is there, and it will not consume anything if it's not used. Consequently, it can have, the FaaS host can have like thousands of consumers at the same time, just listening on various topics. And we just start function when the message comes. If we need to store state, we have a key value database. So we have a very rare system where there's like one connection, one system that will connect as many users, many clients. So multi-tenancy is a real issue for us. First, because we want to provide our Pulsar cluster to all our clients, but also because we have this specific system that needs to connect as many clients, as many identities. So we need function that can subscribe to topics. And right now, the way the Pulsar protocol is done, there's only one authentication context. So when we create the connection, we say, okay, we have this authorization and that's it. So do we need to have like one TCP connection per consumer? This can be a real problem. So we got a new nice solution based on Biscuit, which is a new authentication and authorization system that we've developed for the past 2 years. So it's a mix of JSON Web Token, has its decentralized authorization system that uses a public key cryptography system. And it's a bit like the macaroons. Macaroons are tokens that are bearer tokens that can bring with them caveats to reduce the scope of a token. So if you have a valid token, you can just decide to change the token even without talking to the server that issued the token. You can change the token you have to reduce the rights. Like saying, okay, I have a token that gives me access to a file. Now I will say the new token can only access that file between midnight and 1 a.m. You can do that kind of thing. And so Biscuit can do this, but with a JSON Web Token decentralized system. The caveats, the rules that define what the token can do, are based on a Datalog variant. Datalog is a logic language system. If you know about Prolog, Datalog is a subset of Prolog. That's still very powerful. And all the verification is decentralized. You only need to know the root public key that was created for the first token to validate all of the tokens that can be derived from there. And the attenuation, so generating a new token with less writes from one, that can be done also in a decentralized fashion without talking to a server. And this has been integrated in Pulsar. We have a plugin that you can put in your cluster. Currently still in deployments, we are tuning the authorization rules, but it's been quite interesting to work on the Pulsar code base for this. So what can we do with Biscuit right now? We can start with a token that has full access to a namespace. As a side note, right now, since we're trying to do a multi-tenant system, but at the tenant level, we cannot have access to all of the policies. We plan to give access to a namespace per client instead of a tenant per client, but this might change if the policies change in the future. So we give a client a token that's been generated with full access to their namespace. And the client say, okay, I have a team that needs access to Pulsar, but I don't want them to be able to change the policies on the namespace. So I only give them access to a list of topics with a prefix, or we could use a regex or something like that. And they can look up, produce, consume on any of these topics. Cool, so now they can work with Pulsar, they can test their system. Now they want to deploy their application. They will take their token. Still, no need to talk to the server that issued the tokens. They can just take their own token and reduce the right to say, okay, now the application that we deploy will only have the right to subscribe on one specific topic with a fixed subscription name. We can do things like that. And all of this will be validated by the Biscuit Pulsar authorization plugin, and they can be used right now with the Pulsar admin or Pulsar command lines. And so how can this go back into the functional service system we have? Well, this will solve our problem of having multiple consumers and trying to just reuse a connection, because we can have a function that comes with its Biscuit token, and we can take the set of rules that are used in the Biscuit Pulsar plugin and just validate them locally in the FaaS host, and use a connection with more rights, with quasi-admin rights, to subscribe and produce from the FaaS host on a limited number of connections. So there were multiple steps there, but from Biscuit, the authentication authorization system, to Biscuit Pulsar, to the FaaS, we heavily integrated, and like it works quite well. And so from there, we still have some needs because we've pushed the system a bit far. And like I'll let Alexandre take over there and tell us about what we currently need in Pulsar.
You need to stop your share screen.
Yep. Go ahead.
Okay. So you can see, you see it?
You're not in presentation.
Okay, so I need to, okay.
All right.
Okay, so you see.
No, you're on your block note.
Okay. I'm sorry about that. Okay, it's better now?
Yep.
Okay, so to do this, there are some needs we have contributed to on Pulsar, and one we are still needing. So the first one, available since version 2.5.2, the authorization service provides more granularity. So we introduced topic operations, namespace operations, policies names like offload, retention, and so on. So Biscuit Pulsar is able to contextualize informations to check authorizations. So here you can see that authorization services got this method as example. So allow policy namespace policy operation, and so you have a contextual information that are verified by the authorization plugin. So, as Matteo explained in the future of Pulsar during the first keynote, Pulsar will define policies at tenant and topics level to add the granularity and resources policy. So it's about the PIP 51 describes this. This is a great features to enable the FaaS host to manage publish in different tenants with having its custom policies. So protocol handlers is an amazing feature that enables to run Kafka, AMQP, and Pulsar and using dedicated clients. Like you can use the RabbitMQ official client to connect to Pulsar using AMQP. But proxifying is quite hard, like on Kafka. So it's very complicated, but its feature will be awesome to manage connections to brokers and resiliency. So the FaaS functions will be more resilient, will have more resiliency. So now about the topic completion. So it's currently not on the fly. There is a little delay that you can set between each compaction. So on the fly compaction would enable to use Pulsar topics or event stream storage. So this feature is interesting on function as a service functions that will have their configuration topics. So a compacted topic will reduce configuration time by dumping all the configuration topic from a compacted topic. So another thing is about on FaaS, we can imagine a function that need to consume to a lot of topics the same messages. So patterns as exchange or fanouts at broker level would be reduce the TCP interaction, for example. So it's better on a performance. And the last one is about metrics. The Pulsar component metrics are currently exposed via Prometheus endpoint. At Clever Cloud, we would like to contribute to add a feature that enable Pulsar components to directly push their metrics or the chosen metrics to a defined endpoint, probably using time series standards. So basically define another way than polling. So in that context, we can imagine having the topics used by the function to send their metrics directly to compute the bill. So that's enough. We've finished. So Geoffroy and I will thank you, the organizers for the very nice virtual conference, and of course for attending to our talk. We hope FaaS and its underneath components interested you, and we have sometimes for a Q&A. Thank you.
All right, you should remove your Slack screen.
Okay. Okay.
All right. I have also another Pulsar need is like maybe cleaning up the errors returned by the Pulsar protocol, because like if I am reconnecting for any reason, like there's a proxy that was restarted or something, sometimes I get null pointer exception in a string in the binary protocol from my Rust client. I do not know what to make of that. So, any questions?
So you saw there is 2 questions in the conversation tab. You see it?
I see the Q&A. I see no questions.
On not on Q&A, on the conversation tab.
In chat.
I can copy them. On
I do not see. Oh, okay,
well, I
fine.
can tell you. You see them?
Yeah.
Okay.
So why not just run the function directly in the process of container instead of a virtual machine? So the idea is that a virtual machine is just a container for code at the most raw level, and it's extremely fast to run code there, and you do not have to care about how it will be contained, how it will be sandboxed. You know that the CPU is just guaranteeing that you won't go outside of your memory space. It's something that's extremely powerful compared to containers, for which the idea is that you will try to remove as much access to the kernel as possible, and it's been secured. There's been a lot of work on that, but still people can find ways to escape that they will not find in our system. And the second question is there a risk associated with authorizing a token in the FaaS host instead of the Pulsar cluster? So it's the same implementation. We've done both the Rust, the FaaS host is in Rust and the Biscuit Pulsar is in Java. We did both implementations. They're applying the same rules with the same logic engine. So if we take a token and verify that it's authorized for this topic, whether we do that in the Biscuit Pulsar plugin or in the FaaS host, there's no difference. So no, it's not that risky.
And there is a new question on the Q&A.
So what language is supported?
Yeah.
So right now we have as first tier Rust and C because they are the easiest to support, and we've done a lot of work on Go with TinyGo, assembly script, Kotlin. I'm trying to integrate Haskell and Lua. For most platforms, there's not that much difference to support them. Rust and TinyGo are the most fun to use for this system, because like Go, you just write 10 lines and you have your function and it's all right.
All right, awesome. I think that might be all the Q&A that we have for this session. Thanks again, Alexandre and Geoffrey. That was a really insightful session. So we are wrapping up a little bit early from this one, but we will have our next session after a break, starting at 10:40. Interactive querying of streams using Apache Pulsar by Jerry Payne. So feel free to stay on the line right now, or feel free to take a quick little break if you guys have some work to catch up on, and we'll see you back in about 20 minutes. And I'll go ahead and show some other information if you guys need the other track information. There was some little mishap with the track link for the third track. So I'm going to be pulling it up here if you guys want to write down the information so you guys have the correct webinar ID for track 3. If you guys have any questions, always feel free to join the Apology Pulsar Slack channel so that you guys can continue networking outside of these sessions. And we'll see you back at 10:40. Thanks.